Hey there, Mr. Sutton here with the IM3 Honors Chapter 6 Quiz 2 Extra Practice Solutions on Rational Equations and Graphs. On this problem, we need to find the intercepts, asymptotes, and holes of this function and then graph it. Before we can do that, though, we're going to need to factor it. So it looks like in my numerator, I can take a 3 out of there, giving me x minus 1 left over inside. In the denominator, I need numbers that multiply to negative 4 and add up to 3. So negative 1 and positive 4 would do the job there. X minus 1, x plus 4. And we see that the x minus 1s are going to cancel, leaving us with 3 over x plus 4 for the simplified version of this. Now that we've got that simplified, let's go ahead and find a few things, starting with the x-intercepts. These are going to be x values that make the numerator, the simplified numerator, 0. The problem is the simplified numerator just has this constant 3, which you can write equals 0, but it's not true. It does not equal 0. It never will equal 0, so there's no x-intercepts. For y-intercepts, we have to plug 0 into the original equation here. When we do that, everything zeroes out except for a negative 3 and a negative 4. So 3/4 then, if we reduce that, is going to be our y-intercept. For the vertical asymptotes, those are x values that zero out the simplified denominator, make the simplified function undefined. So if x plus 4 then equals 0, we have a vertical asymptote at x equals negative 4. Holes are going to happen wherever we have factors that get canceled out, and the x values that make those 0 are going to give us a hole. Those are values that would have made the original undefined, but not the simplified. So they're not as bad as asymptotes. So we can say x minus 1 equals 0 for the hole, and then x equals positive 1 is the x value where the hole happens. There's a y value too, but we have to graph the function before we can see where it is, or you have to plug 1 back into the simplified function. Either way. All right, so now we have to talk about horizontal asymptotes. Now looking at the relative degrees of the function, the original function, we see that we have a first versus a second degree numerator versus denominator kind of line up here. This is a bottom-heavy function, higher degree on the bottom. So the horizontal asymptote is automatically y equals 0. All right, at this point, let's graph out what we've got. We may need to get some more points depending on how much information we have, but we have enough to at least start the process. We'll start with the y-intercept of 3/4. So that's going to be right about here. And the vertical asymptote at negative 4, vertical line at negative 4. The hole will hold off on. The horizontal asymptote at y equals 0, we can just draw that a little more dashed on the x-axis. And we see we're going to need some additional points. We only have 1 point, and it's on the right side of the vertical asymptote. We need something on the left side as well to figure out whether we're going to be in the upper left or the lower left for that branch of the rational function. So I'm going to plug in a number over here, like negative 5 or negative 6. Let me go with negative 5, and I'll put that in the simplified function here. It's totally fine to do that as long as you're not plugging in the x value of the hole. So we've got 3 over negative 1, which is negative 3. So we have negative 5 comma negative 3 right here, giving us another point. At this point, I can go ahead and graph the two branches of this rational function. So I have a branch that's hugging these asymptotes and going through this point in the lower left. And then I have another branch hugging the asymptotes and going through this point in the upper right. The last thing I have to do is remember this hole here. I have to put a hole on the graph at x equals 1. So I just go over to x equals 1, wherever that is on the graph, stick an open dot there, and call it a day. For this problem, we want to find all the key features and then graph this rational function. We can't really, we could maybe factor this, but it's not going to help us simplify, so we'll just hold off on factoring until the first thing I'm finding here, which is the x-intercepts. So those are going to be x values that zero out the numerator. To figure out what zeroes out the numerator, I need to actually factor it. So things that multiply to negative 4 and add up to negative 3, that would be x plus 1 and x minus 4. So setting each of those equal to 0 and solving, I get x equals negative 1 and positive 4 for the x-intercepts. Next up, the y-intercepts. If I plug 0 into the original function, let's see what happens. So I end up with negative 4 over 0, which is just undefined. So there are no y-intercepts. For vertical asymptotes, those are things that zero out the denominator. If I set negative 3x equal to 0 and solve, I get x equals 0. So that's my vertical asymptote. There's no holes here because nothing canceled out, no common factors canceled out. Horizontal asymptotes, well, this is a top-heavy function, second versus first degree. So that because it's top-heavy, there's no horizontal, but there are slant asymptotes, which I can find if I divide the numerator by the denominator. Now, since I just have a monomial down here, just a single term, I can just divide each of the numerator terms by this negative 3x. I don't have to use synthetic division here. So dividing everything by negative 3x, so we have x squared over negative 3x minus 3x over negative 3x minus 4 over negative 3x. We're just going to go ahead and simplify this, and that'll give us the slant asymptote. We have an x canceling in our first fraction, ending up with x over negative 3, which I can rewrite as negative 1/3 x. For the next one, basically I have negative 3 over negative 3, which is plus 1. That one wasn't so bad. And for this last one, we actually can just ignore it because slant asymptotes, those are happening as x gets very positive or very negative. So as x gets super big, this denominator gets infinitely large and basically pulls this whole fraction down to a value of 0. Super large denominator means super small fraction that we don't really have to pay attention to. All right, we've got some information. Let's put it on the graph and see if it's enough to actually draw everything. We may need some additional points, I don't know, but let's see what we've got so far. So for these x-intercepts, we have negative 1, that's going to be right here. Positive 4 is over here. We had a vertical asymptote at x equals 0, so there it is. And then we had a slant asymptote at negative 1/3 x plus 1. So there's a y-intercept of 1 right there. And the slope of that slant asymptote is down 1 over 3, down 1 over 3. So draw a downward slanting line there. And it looks like we actually have enough information to draw the two branches. We've got points on either side of my vertical asymptote. So I'm going to draw a branch that hugs the asymptote and goes through the point on the left side and does the same thing with the point and the asymptotes on the right side, like so. There were no holes to worry about at the end of this problem, so this is as good as it gets. To solve this rational equation, a good step would be getting rid of all those denominators. So to do that, I'm going to multiply all my numerators by the least common denominator, the LCD. That's going to cancel out all the denominators. The LCD is going to have everything I need to cancel out each of these individually. So x squared would do it for all three of those. So I'm going to multiply x squared by all the numerators. So we have a 1 upstairs in the first fraction and the second fraction, and also this 4 is going to share the numerator as well. Going back through and canceling out what I can, the x squareds cancel completely in that first fraction. We have an x canceling out in the second fraction, and the x squareds completely cancel in the third fraction. Going back and cleaning this up, we have just 1 for that first fraction, minus, we have a 1x, and then that's all going to equal, we just have a 4 over there. So this is a very quick equation to solve. We can just add x over here and subtract 4 to get negative 3. Let's just go back and check, though. If I plug negative 3 into the original, you'll notice that I don't get 0 in any denominators. We always have to check this with rational equations. Since negative 3 does not make the original undefined, then that means negative 3 is a good answer, and we are finished. To solve this rational equation, I need to get rid of these denominators. So a good way to do that is figuring out the LCD and multiplying all the numerators by it. For my LCD, though, I need to have these things factored so I can tell what I'm looking at in terms of common factors. So this 1/2 is good, but this next fraction, the denominator, I can take out a 2v, leaving me with a v minus 1 downstairs. And for this fraction on the other side of the equals, I can factor a 2 out of there, leaving me with a v minus 1. So my LCD is going to have everything I need to cancel out all of the denominators. So we definitely need a 2 in the LCD. We're also going to need a v for this v right here. And we're also going to need a v minus 1 for these v minus 1s. Just 1 is enough, though. Now I'm going to multiply all these numerators by the LCD. So this 1 here gets it, so does this 1 up here, and so does this v minus 5, which I put in parentheses to be safe. Going through and canceling things, these 2's are canceling, then the 2v v minus 1's in that second fraction, and the 2's here, and the v minus 1's, but not the v. We've got to be careful there. Going back through and cleaning things up, we have a v getting distributed to v minus 1, so that's v squared minus v. Here we just have a plus 1. That's kind of satisfying. Over here we have a v times a v minus 5, so v squared minus 5v. And let me clean this up a little bit. I was thinking of moving everything to one side, but you'll notice these v squareds are actually going to cancel out when you subtract. So really I'm just going to add v over to the right side to get a negative 4v over there. I'll have a 1 left on the left side, and dividing very quickly gives me negative 1/4. Just checking, if I plug that back into the original equation here, or the factored version, I'm not going to get 0 in any of the denominators. So because that doesn't make the original undefined, this is our good final answer.